Alright, welcome to 2-7 one-step equations part 1. We're going to do one-step equations quite often in the next few chapters, so this is just the first one here. Okay, our last lesson was combining like terms, and that dealt with variables. If you look at the examples today, we also have variables, but we're not combining them quite yet. Okay, our next lesson will be graphing in the coordinate plane. Our objectives today, I will be able to write true equations and find the value of variables to make equations true. So we have 1, 2, 3, 4, 5 vocabulary words today. I crossed out that undo because we don't actually use that word very much. We do it a little bit, but that's okay. Okay, so we're going to start off with equations. We need E for equation. So E is on page 5. And we're doing equation. Okay, an equation is two math phrases equal to each other. So for example, down here, we have 3 plus 2 equals 5. That's an equation. Or we could have v minus 9 equals 15. We don't know what v is, but that's what an equation is. So a personal connection would be like you equals your name. So when I say your name, you know that I'm talking to you. Okay? So a personal definition, how would you describe these in your own words? I would maybe say something with an equal sign. Equal signs are important on this one. Okay, now we're going to go to true equations. So that's in the T's, all the way back on page 19 for the T's. Okay, so true equation is when two phrases are equal. Okay, when they actually work out. So for example, 6 is equal to 12 minus 6. And 15 equals 10 plus 15. These are true. When I do 12 minus 6, I get 6. When you get 10 plus 5, you get 15. So a personal connection is like when someone actually calls you by your name. If they know your name and they call you by that name, then it's true. You know that they're talking to you. Okay? False equation. So going to the F's for false. So that is on page 6. Okay, so a false equation is like when two math phrases aren't equal. So for example, 6 plus 2 equals 37. That is not true. That is false. And 9 minus 4 equals 0. Again, that's false. If I do 9 minus 4, I don't get 0. So these are false equations. And a personal connection would be like when someone calls you by the wrong name. So if you're, like for me, my name's Mrs. Morell. So if someone called me Miss Sawyer, I wouldn't know that they're talking to me because it's not true. Okay? So it's kind of like a personal connection. If they call you by the wrong name, it's not true. Okay? Next, I believe we're going to do addition property of equality. So it's on the very front page. It's A. Okay, and this one has a lot of writing, so you might need to pause. Okay? So if you add a value to one side of an equation, you must add it to the other side. Okay, so in this case, if I do x plus 2 equals 6, I'm going to add negative 2 to one side. I have to do it to the other side. So this is the line, so you might want to highlight this line. That's the addition property of equality. Okay, and then I continue to solve it. So for example, if you have little siblings, this happens all the time. So if you have a little brother or sister, all the time, or if you babysit. If you give your little sister candy, you have to give your little brother candy. So if you give it to one side, you have to do it to the other side. Okay, and last word is isolate. So isolate is going to be on page 10. It's on the second page of the I's. So there's 2 I pages. It's on the second page of the I's. So for isolate, our academic definition is to separate something by itself. So for example, if we solve this equation, x minus 2 equals 4, we would add 2 to both sides. We get x plus 0 equals 6. So isolated would be x equals 6. X is by itself. It's all alone. Okay, so a personal connection would be like if you get sent out of class, your teacher is isolating you by sending you out by yourself. So that's isolate. Okay, all right, going to your notes. All right, so fill in the equations to make the following equations true. So 3 plus what number equals 0? Well, we have to go backwards because we're at a positive. So we're going to put in a negative, and that'd be 3 plus negative 3 is equal to 0. Okay? Negative 2 plus what is 0? Well, I have went backwards 2, so to get back to 0, I have to add a positive 2. 4 plus what number is 4? Well, 4 plus 0 is 4. Negative 2 plus what is negative 2? 0. And x plus what is x? And that's 0. We're going to use these a lot today. Those ideas that to get back to 0, we add the negative or we add a positive, opposites. And then when we add 0, we always get the same number back. Okay, here we go with example 1. So it says solve the equation x plus 7 equals 9. I'm going to rewrite it here because that's where we're going to show our work. Okay, so we need to isolate x by undoing. So if I draw a line down the middle of my equal sign, that allows me to keep things separate. So right now the x is with 7, and we need to isolate x, get it by itself. So we have to undo or get rid of adding 7. So to undo a positive 7, we want to make a 0. So we're going to add negative 7 to both sides, and that's that addition property of equality. So I'm going to add negative 7 here. If I do it on the left side, I have to do it on the right side, on the other side of that line. That helps keeps us organized. Okay, now we're going to actually add, so the x comes down, plus, what's 7 plus negative 7? Well, 7 and negative 7 is 0, and 9 plus negative 7. So I have a positive and a negative, so I subtract. 9 minus 7 is 2. And there was 9 positives and 7 negatives, so there's more positives, so it stays positive 2. Now we're going to simplify, and that means x plus 0 is really just x, so you get x equals 2. Last thing we're going to do is a quick check. So if I go back over here and I plug in 2 in for x, and I write 2 plus 7 equals 9. Is that true? If I think to myself, what's 2 plus 7? That's 9. Does 9 equal 9? Yep, it does. Okay, number 2. Solve the equation 5 plus d equals negative 13. So I'm going to write that here. 5 plus d equals negative 13. I'm going to draw a line down my equal sign so that way when I do my addition property of equality, I can think both sides. So we need to isolate, this should say d, not x. Isolate d by undoing. So d is currently on the same side as a plus 5. So we need to undo adding 5. So to undo adding a positive 5, we're going to add negative 5 to both sides. So if we do it to one side, we do it to the other. Now this time I'm going to put it right underneath that 5. So to get rid of a positive 5, we're going to add a negative 5. And then I do it on the other side, so plus negative 5. Now I'm going to add. So 5 plus negative 5 is 0. Plus d equals negative 13 plus negative 5. They're both negatives, so I just add like normal. So 3 plus 5 is 8. Bring down the 1. And they're both negative, so I'm going to make that a negative. Then we're going to simplify. So 0 plus d really means d equals negative 18. Last thing we're going to do is check. So I'm going to write it over here. So does 5 plus negative 18, does that equal negative 13? Okay, well one's positive and one's negative, so I actually subtract 18 minus 5. 8 minus 5 is 3. Drop the 1. I have more negatives, so it'll be negative 13. So yep, it worked. That one I couldn't do in my head, so I showed some work. Okay, back page. We're going to solve the equation negative 12 plus p equals 65. Okay, I'm going to write that again right here. Negative 12 plus p equals 65. Okay, so we need to isolate x, but there is no x. I meant to write p. Isolate p by undoing. So p is here, and we have adding a negative 12. So we need to undo adding negative 12. So to undo that negative 12, the opposite of adding negative 12 would be adding a positive 12 to both sides. So to undo adding negative 12, I'm going to add 12. I'm going to write it right underneath that negative 12. If I do it to the left side, I have to jump over that line and do it to the other side. Otherwise, it's like giving your little brother candy, but you don't give any to your little sister. And we all know then your little sister cries, right? And then you have your little cousin crying and lots of other people crying because candy is so good. Okay, now we're going to add. So negative 12 plus 12 is 0. Plus, we drop down that p equals. And now 5 plus 2 is 7. 6 plus 1 is 7. They're both positive, so I just add like normal. Last step is to simplify. So 0 plus p is really just p. So p equals 77. Last step is to check. So if I plug it in over here, negative 12 plus 77, does that equal 65? Okay, so I can double check that by doing 77 minus 12, because one's positive and one's negative. 7 minus 2 is 5, 7 minus 1 is 6. And there's more positives, so I did get 65. Number 4, you're going to solve this equation, h minus 18 equals 66. When I rewrite it, I'm going to make this subtracting into adding the opposite. So I'm going to say h plus, what's the opposite of 18? Negative 18 equals 66. Okay, so we need to isolate h, not x, that's an h. Okay, by undoing this adding a negative 18. So to undo a negative 18, we add a positive 18, and we do it to both sides. So I'm going to put it right underneath this negative 18. So add positive 18, add a positive 18. So this h drops down, plus negative 18 plus 18 is 0. They're opposites. These are both positive, so I'm going to just add like normal. 6 plus 8 is 14. Carry the 1. So 6, 7, 8. So I'm left with h plus 0, which is just h, equals 84. Okay, so I want to check. So to do the check, I'm going to plug that in for h. So does 84 minus 18, does that equal 66? Okay, I can't do that in my head, so I'm going to just jot it down, 84 minus 18. So I'm going to borrow, that becomes 7. 14 minus 8 is 6. 7 minus 1 is 6. So I got 66, so it worked. That's a check mark. Okay, number 5, last example. We're going to solve the equation p minus negative 73 equals negative 92. When I rewrite it, I'm going to change the subtracting a negative into adding a positive. So I have p plus, what's the opposite of negative 73? That would be a positive 73 equals negative 92. Okay, so we need to isolate the x. I'm going to draw my line. And here again, it's a p, not an x. I just copied and pasted that. By undoing the adding 73, we don't want that there. So to undo adding 73, we're going to add a negative, oops, I don't know what that is, negative 73 to both sides. So I'm going to put it right under that 73. So add negative 73. Okay, drop down the p. Plus 73 plus negative 73 is 0. Equals, now these are both negative, so we just add like normal. 2 plus 3 is 5. 9 plus 7 is 16. So negative 165. So I end up with p equals negative 165. Okay, now we're going to plug that back in for p and see did it work. So if I have negative 165 minus negative 73, does that equal negative 92? So subtracting a negative is the same thing as adding a positive, because we add the opposite. So opposite of negative 73 is a positive 73. So since one's positive and one's negative, positive, negative. I'm going to subtract 165 minus 73. So 5 minus 3 is 2. 16 minus 7 is 9. And I have more negatives, so it turns out negative. So it did work. Okay, we use the addition property of equality. To solve equations. To undo addition, we add the opposite to both sides of the equation. So every time is always the opposite. So if we're trying to undo adding 73, we add negative 73. Then last step is to check your answer by plugging in the value for the variables. And that's it.